Now, in our previous part of this lesson, we identified how we could have factoring in a similar way to what we do with variables. But if we try to do that with division and factor things out, like cancel them out, that can cause us some loss of solution. So for instance, if we had a problem that was 2x is equal to 6, we would normally divide everything by 2 and say x is equal to 3, right? So if we use the same logic, we would say something like 2 times the sine of theta equal to the sine of theta. Well, we would factor out the sine of theta, right, on both sides and say that 2 would be equal to 1. Well, you can automatically see how that does not work. This in itself, because we have an unknown over here or something that we don't know what this answer is, we can't use that variable divided by itself because 2 does not equal 1. So we get a loss of solution in that way. So in order to handle these types of problems, we have to set them equal to 0 in order to factor them. We cannot divide because it is an untrue solution, or at least an incomplete solution. So let's jump in and I'll show you what I mean with the first practice problem. For these, you will still need the unit circle, so I'm going to add that as well. So when we have a problem like 60.4 that tells us 2 times the sine of theta times the cosine of theta is equal to the sine of theta, we can't just divide by the sine of theta because then we lose the value of the sine of theta as a potential answer. So instead what we do is we set this equal to 0. So in factoring these trigonometric problems, always set the equation equal to 0. And when we do that, we find 2 times the sine of theta times the cosine of theta minus the sine of theta is equal to 0. So now we can manipulate this side as its own entity, right, without comparing it over here. This allows us to find all of the possible solutions without getting rid of sine, and it keeps it a true statement. So what we're going to do, however, is we're going to treat this very much like we would have treated x squared plus x equals 0, and we're going to factor out what's in common with both of the terms. And in this case, it's sine of theta. So we would say the sine of theta times 2 times the cosine of theta minus 1 is equal to 0. And that allows us to get solutions for sine and solutions for cosine. So sine of theta is very simply the sine of theta is equal to 0. We set that equal to 0. And then we have this other factor, which is 2 times the cosine of theta minus 1 is equal to 0. Well, we add 1 to both sides. We get 2 times the cosine of theta is equal to 1. And then we divide both sides by 2 and find that the cosine of theta is equal to 1/2. So now we're able to find what is theta. And so we need to find where the sine of theta equals 0. So we look around our unit circle, and here we have it at 0. So the sine of theta, or theta, could be equal to or is equal to 0 degrees. And if we continue around, we see that the other place where theta is 0 degrees is going to be, or the sine of theta is 0 degrees, is at 180. So that's our other solution for theta, the degree of angle that would make this a solution set. So those are the only two places where the sine of theta is 0. So now let's look for where the cosine of theta is equal to 1/2. And so in the cosine is going to be the first term. So in looking around for the cosine where it's at 1/2, I see 60 degrees right here. So 60 degrees, and that's a positive 1/2. Keep that in mind. Here's a negative 1/2, so that's not true. Continuing around, now we have a positive 1/2 at 300 degrees. So the other and final solution for this solution set for the degree of theta is 300 degrees. Because if we continue looking, We do not find another cosine where theta is equal to a positive 1/2. So this would be our solution set for theta for this problem. So you can see if we had eliminated sine, we would have gotten rid of these first two answers. We would have eliminated potential answers by factoring it out, and that would have been incorrect. So that's what we would do to solve for a problem like that, where instead of having a number or 0 on this side, we have another trigonometric term. We just pull that trigonometric term back over and then look at how to factor that potentially. All right, and that's all we have for lesson 60. We had one practice problem for 60B, and that was it. So I will see you in lesson 61. Be sure to do the practice problems that follow this video, and I will see you when I see you.